So the next thing in line for this part is to mill the radii. They're 1/2 inch radii. Let's take a look at the print here. Where are we? Right there. Okay, you can see it has a 1/2 inch radius milled around on each of these tabs sticking out here. And also we're going to, in milling that 1/2 inch radius, we have to be sure to leave this pad untouched to put the zero mark in. So that's going to be a little tricky. What we'll do is we'll set up on a rotary table and we'll do each of these radii separately. I'll go ahead and do this the one around the pad here first. And to do that, I need to put layout lines on this pad so I know where it is, because I'm not gonna measure. I'm not gonna use the machine to know how close to measure to define that pad. I'm just gonna mill to the line. Okay, I'm gonna put a layout line, lay out the pad, and I'm gonna just visually mill to the layout line. We could do it. I mean, we could calculate how many degrees to crank the rotary table and figure the sweep of the end mill to figure out exactly where to stop. But it's senseless to do that. It's a lot of work to figure that out using trig, and it's unnecessary because it's just for looks. So if it's just for looks, it's good enough just to mill to a line. So let's go ahead and lay out this pad. You can see it's well, from the inside surface of this notch, it's a 1/4 inch long. Where are we at here? There we go. I'm working backwards here. The screen's backwards. Everything's backwards. So you can see the pad is a 1/4 inch long and it's 200 thousandths wide. I'm going to assume it's on center. There should be a center line through here. I'll have to add that to the print. But so we have to put our height gauge on center, then move 100 thousandths each direction to put a scribe line. That'll define that pad. So let's go ahead and do that. I've added some more layout die here in the appropriate spot. Remember, don't get mixed up and put the pad in the wrong place. Always refer back to your print so you know the part's oriented properly. So first thing I'll do is let's go ahead and put that 1/4 inch line down from the inside of this notch. All I'm going to do on that is just run down to set the height gauge on top of that, zero my dial out. Okay, then just go down 1/4 inch, 250 thousandths. Right about there. Put a mark. Alright, we got that figured out, or that laid out. Now I'm going to turn it up like this, and we'll pick up this top surface with the height gauge. Set that on 0. Okay, now I know the center, I know this radius is going to be 1/2 inch, and this block's all finished to size, so I can move down half of that, and it'll put me right on center of this 7/16 hole in here, or right on the center line of the pad. So let's move down 1/2 inch. 500 thousandths. Okay, so now we're on the center line of the hole. Now we have to move up 100 for one scribe mark. Let's see here. Let's lock this down and use the fine adjustment. Okay, there's one. Scribe that one. Now we have to move down 200 thousandths from this point for the other one. 200 thousandths. Okay, so we've got, get it right so you can see it here. You can see I've got 3 scribe lines defining the location of the pad. So that's what I can mill to when I'm doing the radius. So let's move over to the mill, set up the rotary table, and start milling these 2 radii. Okay, so the first thing we need to do is center up our rotary table. Okay, I already have a video out on that, on how to do it with this nifty little plug gauge here, this little plug tool. This thing has, I don't know if you've seen it or not, but this brass cylinder here has a slight bit of taper to it, so if you drop it in the center of the rotary table, it snugs right up, Then you can grab onto this dowel pin with a collet, and it'll perfectly center the rotary table up on your milling table without having to touch an indicator. So let's go ahead and do that. Alright, just run it down into the table till it snugs up. Lock everything in place. Now I can go ahead and center my table up on the slots and lock down the hold downs. Just kind of snug them up a little bit at a time so nothing moves. There we go, right on center. A lot easier than indicating it. Now before I touch anything else, I want to make sure and either center up my dials or center up the digital readout in this case. So I'm going to go ahead and do that. I don't know if you can see this. There we go. Okay, I'm just going to center out both X and Y axis. And that tells me where the rotary table is relative to the spindle. I'm going to leave that throughout the entire machining process for those two radii. Alright, let's get reset up here. Okay, now, so the next thing we need to do is, since I'm going to work on this end with this pad on first, we'll start out there. So all I need to do is put a half-inch dowel pin in the spindle of the mill, or a 7/16 dowel pin. So I've got a 438 diameter pin. Remember, we reamed this hole to 438.5, 1,000th over 7/16. So this pin should fit pretty nicely into that hole. And we'll use the pin into a collet in the spindle to center up the part on the rotary table. The rotary table is already centered. Now we're going to center the part on the rotary table. So let's go ahead and put this pin in the collet. And we'll wait for the air compressor to do its thing. Okay, that thing is... I keep threatening to move that thing up into the attic. Give myself some more room in here and make it a lot quieter, but haven't got around to it yet. So let's go ahead and center up the part on the rotary table. Just drop the this pin into the hole in the part. Okay, that's rotary table's already centered on the spindle. Now we're centering the part on the spindle, so they're all in line. And I got it upside down. I was going to start on the end with the pad first. Let's do that. Now, this is kind of a small footprint on this thing, so the possibility of this part moving as I'm milling the radius is fairly high. So I'm going to put a piece of paper under this thing. This is a good tip for on a rotary table or even in a vise. If you put a piece of paper between the part and either the jaw or the table itself, it'll be a lot less apt to move on you. It's a good tip to know. I was all excited. I thought I'd be able to use my the step blocks I made on the last project tutorial, but they're just a little bit too short for this setup. So I'll have to use my old standbys. And when you're clamping with strap clamps like this, get the bolt as close to the work as you can, and get the step block as far away as you can, so you get as much leverage on this clamp as possible. Okay, we'll just snug it down a little bit. Well, I might as well tighten it all the way down. It's all centered up. Okay. Okay, that didn't feel right. When I pulled the pin out, it moved a little bit, so I think we'll put both of these clamps on. And we'll snug them down a little bit at a time. Keep it from moving on us. Alright, let's see what that does. That's better. Okay. Alright, so now the part's centered on the table. Okay. Next thing we need to do, we need to know when the thing is parallel to the mill table, so we know how far to mill our radius. It's not real critical in something like this, because like I say, it's mostly for looks. But it's pretty easy just to sweep an indicator across one edge of the part. We can move it now because our DROs or our readout's already centered, so we'll just move out here till we move the indicator a little bit, and we'll just kind of adjust the rotary table till the needle stops moving, and then we're pretty parallel to the table. There we go. That's pretty good. I'm going to take the backlash out of this table now, so I'll go past a little bit and then come back clockwise to the same reading. That takes any play out of the screw, and then I'll zero up my dial. Alright, so that should be parallel to the table, and then I'll set my indicator down here to an easy number to remember. Like here it's close to 130, we'll set it at 130 degrees. That'll be parallel to the table. Okay, so we're all set up. Now, first thing I'm going to do is I'm going to throw a 1/4 inch end mill in here, and I'm going to rough it out with 1/4 inch. I'm going to finish it up with an 1/8 inch because it has this small radius, so will look good where it ends up next to this 15 thousandths pad. Big radius, you'll see a lot of radius, and it'll kind of sweep up to the pad. The small one will make it a little more abrupt. So let's put the 1/4 inch end mill in. It's just a 1/4 inch 2-flute end mill. Alright, so now we have to offset the cutter. We have to offset the cutter, the size of the radius plus half the diameter of the cutter to do this radius. Okay, so the radius is 1/2 inch, and the cutter is a 1/4 inch, so that's a half plus an 1/8. So our offset should be 5/8 of an inch. 625, and then I'm going to go 10 thousandths farther now for the roughing cut. So we'll make it, our offset will be 635. Okay, lock the table down. I offset it on the Y. I could have done the same thing on the X. It doesn't matter either way. Now I need to set my X, set the X-axis back up to 0. And just leave that on 0. So now our cutter is on axis and shifted off 5/8 of an inch to mill our radius. Okay, so let's go off to this corner part here where it's all going to go away. So I'll use this to touch off my cutter on the top because I want to know, I know how far down I have to go by the print. Even though I put that line there, I know it's a 1/4 inch from the center, and that tab or that, let's see, this tab is what, 438 less a 1/4. So I should go down 3/16 of an inch. I don't know if you can see that. Should go down 3/16 from the what's now the top of the part. So I'm going to go down and touch the top with this end mill. Let me go turn on the power. Grab my glasses. Okay. So I just run the cutter down till it touches. Zero out my dial on the knee. Alright, 130 degrees. We want to go 180 degrees the other side. There's there's 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. 310's the opposite side. Okay? You have to remember these numbers are all relative depending on where you start. So all you do is just count how many degrees you want to go. So in this case 310 is the opposite side. So now we can go down 3/16 of an inch. 1/875. I'll back off 10 thousandths so I can have a little finishing cut take. So now all I'm going to do is just rotate the part around a little bit at a time and plunge mill it just like I did on the slot. See why I picked the 1/4 inch end mill? Because it's going to take all the stock off. I like plunge cutting, at least for where you're taking off a lot of material. For light cuts you don't need it, but for heavier cuts, in this case I don't want my part to move, so I don't want to load the part down with a lot of side load from the cutter, so plunge cutting is the way to go. Now we have to be careful because I don't want to cut too far here. I only want to go up to my line. So I'm looking at the line that I laid out. And I'm going to stop just shy of it right there. Alright, so now it's all roughed out. Let's go back to the start. I wasn't thinking straight. Let's go all the way around here. The pad is underneath. The pad is the bottom part. This one we go all the way. We don't have to stop at the line. Should have looked at my print. We go right on around to 130. It's the lower cut that we'll have to stop on the line. So now let's go down to the where we cut the hole, make the whole cut. Actually, we didn't even have to take that first cut. We could have just made this our first cut. I didn't realize I was looking at the wrong half of the pad. We don't have to plunge cut. We're taking light cuts in here, so only when it starts getting heavy, then I'll switch over to plunging. And now I have to watch my layout line. I have to make sure to stop before I cut into that line. Right about there. Okay. Let's just crank back to the start. We'll take one more finish cut, and then we can swing around and do the other side. So now we should be able to crank it into 625. Now there. Now I'll just, I'm saying it's such a light cut, I'm just going to climb mill around. Generate a nice radius. I don't want to dwell too much on the end here because it'll leave a divot. Since this is an aesthetic thing, aesthetic part, I'm just going to keep the table moving until I get up to my line, and then I'm going to pull the cutter away from it. Right about there. Okay, kick the cutter out. Now go back to the start. Drop the cutter down the 3/16 of an inch like we did the first time. Take a finish cut on that. Okay, so now make sure you, on the rotary table, it's real easy to crank the dial the wrong direction. So make sure you know what direction you're going to go before you move your cutter into the work. Okay, in this case, I need to turn it counterclockwise. So we'll start from the position like this. Bring the cutter in to 625. As soon as it starts touching the work, I'm going to start cranking it. Stop on 625. Anytime you leave the cutter set, dwell in one place, it's going to leave a mark. It's really not taking anything off here. Won't take anything off till we get around to the other side next to that pad. Alright, here we are, coming up on our 130-degree mark. As soon as I get to it, I'm going to kick the cutter out. Okay, so this side's done. So now, let's flip the part over. Do the same thing on the other side, except we don't have to worry about the pad, so it'll be a lot easier. A lot less stuff to think about. Okay, you can see this. I think you can see it. There we go. You can see we got a nice radius milled all the way around it. And here we stopped on the line here, so it's you're starting to see the pad being defined. Now the other side of the pad it's just a straight milling cut for this top surface. We've got to drop this top surface down 15 thousandths, and that'll expose the pad all the way around. Okay, so let's set up for the other radius. Same way we did the first time. Got to put the 7/16 pin back in, or the 438 pin. And you know what I forgot to do? I forgot to put that 1/8 inch cutter in. I got carried away. I think we're going to just leave it at quarter. Looks pretty good. That dimension's not called out on the print anyway, so it's right either way. Make yours, you can do it however you like. Make sure the paper's underneath the part, so so the part doesn't move around. See if we can clamp this one a little more evenly than the first attempt. Yeah, it feels pretty good. Nothing moved. Pin goes in nice in the bore, so should be good. Just use this 1/4 inch cutter again. Worked so well the first time. Alright, now we got to indicate the part so we know it's parallel to the table. What did I do with my indicator? Here we go. This holder is called an Indicall. It's a real handy holder to use for stuff like this on the mill. You can even put it on the mill with a drill chuck in the spindle. Alright, it's a little crowded here, but I think we can get enough of it to see what's going on. Here we go. Again, it's not very critical. Just have to get close. It gets more critical if you're trying to blend two radii together than a radii with a flat surface. Alright, so we got our dial set on 0. Set this pointer on 130. So now we're parallel to the table. Everything's clamped down. Set the x-axis back on 0. Clamp it down because we're not using that one. There. And we'll offset the Y 635 just like we did the first time, which is a 1/2 inch radius plus half the diameter of the cutter plus 10 thousandths for a roughing cut. And we'll go ahead and mill this up. Okay, you should be able to see a little better what's going on now. Just set our stop here and plunge cut our way around. We'll back it out to 635. There we go. We'll leave 10 thousandths cleanup cut on it. Oh, it's okay, that scared me a little bit. I didn't expect it to touch, but we have that 15 thousandths raised surface on this side, so that's good. So let's just work the way around. A 4-flute end mill would probably be more suitable for this, but I don't do a lot of work in steel, so I don't have a good selection of 4 flutes. So this is a 2-flute. Just have to be aware of that and try not to overload the teeth. This puts more of a load on each tooth, since there's only half as many. It is easy to chip a tooth when cutting steel with a 2-flute. roughed out. We'll go back and take a finished cut and we'll be done with the radii. Okay, right to 130. So we have to go counterclockwise. We'll just feed it into 625. When we start getting close, start moving so it doesn't leave a divot. Rotary table works kind of fun. Gets a little more challenging when you have to make several radii tangent to each other, but it's just a matter of getting used to how to use it. Okay, as we come up to our 310 degree mark, I'll get ready to pull the cutter away right there. So let's see what this looks like. Should be done. Yep, looks pretty reasonable. Starting to look like the part on the drawing. So the next step then, we'll put the part in the vise like this, and we'll end mill the rest of it. We got to take this surface down 15 thousandths. So I'll use a cutter instead of using a cutter with a side milling it with a 1/4 inch cutter. We'll end mill it with a 1/8 inch radius on it, on the corner of the end mill. So we'll set up and do that next, and I think that's about it for this part. I think that'll finish it up. Yep. So let's go ahead and put the vise back on and finish the part up. Oh, one more thing to do. We still have to cut that zero mark on here. I'll show you how to do that. That's kind of a little different process. It's called slotting. I'll show you how to set that up too.